thank you very much in order to participate in this meeting, but especially in order to participate in the project. We are very happy that to have a so important group of countries in this meeting. I would like to, could you show my slide, the second slide, please, Victor? The second slide. And I would like to say that this is a project that we have really a lot of problems this year because, you know, it is a difficult year with the COVID. And I received 74 reports, and we are receiving continuously every day, some of them more. There are in total 22 countries that participate in this. And you can see several examples that people that use normal terrestrial sphere, but there are others that didn't have it and they use a ball, or there are others that use, for instance, an onion, okay? Then the creativity is the much more important, and I am very interested to know your point of view and your presentations. The idea of this meeting is that you explain what you do with the parallel Earth. In some way, is a monographic about the parallel Earth, and our idea is that you talk about this and to collect several of these contributions in a small book about the project and about this concrete activity that we carry out for 1 year, or 6 months. This is much concrete. Then I would like to invite to all of you to ask questions in the chat. Victor Ramirez is my student, is an excellent student and a very efficient person. And he will control the chat, and after the presentations, he will comment the questions to the speaker. Then especially we have 3 lectures. There are short lectures because you know that this is an online presentation. And the first one is Nicoleta Lanciano. If you can put the next slide, Victor, please. Nicoleta is a professor in the Università La Sapienza de Roma. Is a person very well known in the area of astronomy, and especially is a researcher in how the students learn astronomy and in general how students learn all science contents. Then I would like to begin that Nicoleta to present the PowerPoint. He has 10 minutes for the presentation, and after we have 5 minutes for questions. Thank you. Nicoleta, it's your turn.
Thank you. Can you see? It's okay? You can see, Rosa?
Yes.
Okay.
It's okay. Very well. Yeah. It's okay.
I have. You see? Because I can't. I have a problem. You see the... No.
We can see the first slide.
Very well. It's the first slide.
Okay.
The international...
I am Nicoleta Lanciano from Rome, Italy, North Hemisphere, and English is not my mother language, so I hope to well explain my thinking in this language. I began from an experience from my perception in Brazil, in the Atlantic coast. Yes? Problem?
We didn't see the PowerPoint now.
You don't see?
Didn't see the PowerPoint now. We have another PowerPoint. Not now.
I try again. Now?
Yes, now we can see.
Yes, now yes.
Okay. Okay.
Now yes.
I began from an experience, from my perception. I were in Brazil, in the Atlantic coast, and I saw the Big Dipper constellation going down under the sea. It was very strange for me. The North-Occidental myth is contradicted on two planes from this vision. On the narrative plane, because of the myth is linked with the place where it was born, with the perception of people in the latitude of Mediterranean. And on the astronomical plane, because in Italy, Big Dipper is a circumpolar constellation. Why the Big Dipper was going down under the sea in Brazil? Because of the Earth is spherical. And looking from Brazil, the polar star is under the sea, Italy is under the horizontal plane, and perceiving from South Hemisphere, the North Hemisphere is down. Relationship between up, down, and north, south were really very clear at this moment. And in Brazil, I felt that I was on a spherical planet. I had yet a laurea in mathematics, and I worked for my doctorate in didactic of astronomy, but a perceptive and direct stumbling block was necessary to produce a conceptual change and modify my feeling and my vision about the Earth in a very deeper dimension. Starting from this perception, we elaborate the Mappamondo Parallelo, the parallel globe, oriented like the planet Earth and homothetic with the Earth. So in the same position of the model and the planet. And in 2010 started the international project Globo Local, a liberation movement of the globes from their usual position like this to a local and democratic position in every country. I will explain better. It is a project of democracy to help perception in learning astronomy under the sky of every country, also in the tropic countries, in the south countries, to see the night, season, time zone. This is the website that is very old, is in different languages, like you can see Italian, German, English, French, Portuguese, Spanish, Russian. But okay, it's a little old, but there is a lot of material. The project involved some investigation, for example, about initial conceptions about Earth, in this case, the Earth, the rain, and the clouds. And we have from adults and from children pictures like this, Why we have this people that knows that the planet is a sphere, that is three-dimensional, but they have an idea of the top absolute for the Earth. I think that is a problem because people don't work enough with different dimensions of space in geography, astronomy, geometry, but we work too much in the classes, in the small spaces, and we work about microspace with little objects in the and not enough in the mesospace, macrospace, and megaspace of astronomy. For example, the vertical direction in the mesospace, like you can see here on the, on the with the people on the ground, the vertical direction is perpendicular to the ground. But if we think in a megaspace, a planet, the vertical direction is radial to the center of the spherical planet. This mental gymnastic is necessary to well understand astronomy. So the parallel globe can be very simple, only put on a glass, or more sophisticated, and we can read the angle of latitude and so on. So we began with a lot of photos from different countries, from equatorial countries, tropical countries, from the South Pole, Antarctica. There is an Italian basis, and on the equator line that is marked also on the planet if you travel, and especially for to look well equinoxes and solstices and so seasons, we worked with Nestor Camino from Argentina with a white sphere where we mark every hour the terminatore between shadows and light. And so in the upper sphere, you can see what happens in the north, near the North Pole, and in the same day, that is the solstice of the solstice of December, and in the North Pole is always night, and in the South Pole is always the day. So we have finally the sphere in the equinoxes, all the line, the big circle pass from the North Pole or the South Pole, and in the solstices, they are around the Arctic Circle or the Antarctic Circle. So we can see very well what happens for the day and night in two important moments of the year that are equinoxes and solstices, and that are the limit situation in the year for the time. So we observe the globe here and now in every country, but in every moment, but we understand and we can see what happens on the entire globe. And it's very important, the dialogue between different registers of representation to better and deeper understand our position on the Earth. We began with our local topocentric, our local horizon, and we put our horizon on the map, on the plane map, and finally on the sphere, on the parallel globe. So the same experience is listened, and we can reflect in different registers. It's very important because plane maps give a lot of confusion. So it's very important to see what happens on the sphere and on the floor, flat floor, because we can see the shadow in every situation. And I like a familiar metaphor to speak about our ancestors, like the Globo di Matelica, a Roman globe. And we have some cousins in the, for example, in Europe, la Bola del Piquillo in Santander, in España, or il Globo of the Museum in Monaco, Germany. La Bola del Piquillo was now is very well. Before it was very bad because someone who, after a lesson with me, perhaps, and Rosa, a lot of time ago, understood what it was. And in Murcia, the very big parallel globe is a children of my lesson. We agree with Obira Pandambrosio from Brazil that the intercultural perspective removes each science from a supposed neutrality and assigns it the explanation of an ethical and political perspective. This is our perspective. Like this, we began our work. And for the maps, the relativity of points of view is symbolic, geographical, cultural, and it's a challenge for the people of the North, for the West, for the rich and technological countries. And we have to know that behind the map, there is an implicit, hidden, sometimes dangerous power. So we like very much this. Yes, okay. Thank you very much.
Okay. Then I don't know if there are any questions, maybe. Victor, we have any questions?
Well, in the chat, there are not questions, but there are some comments. For example, Akita, well, has said that it's impressive that drawing the light shadow lines. And then Jose Manuel Escobedo is surprised because Metallica is Roman period, but there are not specific questions.
Okay.
Thank you.
If you want to say 20 seconds or something like that, Nicoleta, because we are in time for the next one speaker.
Thank you.
Do you want to add something more? Okay. Then, Tomita, are you ready to introduce your presentation?
Okay.
It's the previous one. No. Tomita is before Indonesia. Victor. No.
From Japan. Okay. So can I share my presentation?
Yes. Tomita from.
Okay. So first
It's
of all.
from the Wakayama University.
Okay. Yes. Hello. I am Tomita from Japan. I'm very happy to be with you. Nicolata's presentation was so impressive, especially drawing the light and shadow lines is very educational. So my presentation is not so educational now, just showing some pictures taken in Japan. Okay, so I will share my presentation. Okay, please wait a minute. Okay, so can you see my presentation?
Yes, we can see very well.
Okay.
Beautiful.
Okay, so we held a NASA course last year in Japan. Thank you, Rosa and Beatrice. About 60 teachers and citizen astronomers joined the course. So I called the Parallel Earth a global local practice to the participants, including teachers. Many enjoyed the Parallel Earth. I will show you some photos I gathered so far on the autumnal equinox day. We sometimes have a rainy season in late September, but this year, luckily, it was a fine day. Okay, so this photo was taken by a staff of the Science Museum called Sato Tanaka. She is one of the active astronomy educators in Japan. Okay, so just on the autumnal equinox day, so in Japan, the latitude is about 35 degree north. So the globe is tilted 35 degree, and on the equinox day, so the sunlight equally on the northern and southern hemispheres. Okay, so this is one example. Okay, so this photo was taken by a school teacher named Hanai Senior High School in Osaka City. The photo was taken by the school teacher named Masazumi Tsujimoto. Okay, so he is one of the very active astronomy school teachers in Japan. I'm very happy to show his photo like this. Okay, so this photo is also taken at the autumnal equinox day. Okay, so this is another example. At home. At home is a nice practice under this so-called social distance circumstances. So I hate the term of the social distance because we need the social distance to be very small. Okay, so anyway, at home, at school, at the city road, in front of the temple, we can enjoy the global local parallel earth practice. Okay, so this is the last photo. This is me in front of one of the oldest temples in Japan, Shitennoji Temple in Osaka City. Okay, so this photo was also taken at the autumnal equinox day. So you can see in the left hand, the sunshine was equally to northern and the southern hemispheres. Okay, thank you very much. So this is the photos I gathered in Japan. We are under one sky. Thank you very much.
Thank you very much, Tomita. I don't know if there are only one question maybe, because you are exactly at time. We have any questions in the chat, Victor?
No, there is no question. Only Jose Manuel Escobedo that says, good job.
Oh, thank you.
And wonderful picture. I love the last one. Sorry. It's a very beautiful. Thank you very much. The next speaker, thank you. The next speaker is from South Korea. And we would like to mention here that, no, it's not this PowerPoint.
No?
We have one problem. No.
Oh.
No,
Victor is the PowerPoint.
Okay, sorry.
no,
Yes.
no.
Okay. Okay. Welcome. I am very happy in order to introduce to So Yoon Cho. I don't know if I pronounce very bad. Sorry.
I'm here.
She's one student of the Incheon Yeson Middle School. Her teacher, Nicole Yin Kim, suggests that she could speak about the presentation because the teacher have difficulties with English, and so you show speak English, I am sure very well. Then it's your turn.
Okay. May I start now?
Do you have the PowerPoint?
Yeah, I have a PowerPoint.
You have to share with us. I don't know. It is,
And
we have
may I
a
start
problem.
May I start? Like, is it okay with everything?
No, not very good. I don't know what is the problem. Victor, could you help us?
Yes, I don't know
We
because
didn't see.
I can see it good now. Okay.
No.
Okay, is it okay?
Yes. Oh,
Okay.
No.
now no.
No.
Before we observe.
Now.
No, yes.
Okay. No.
Move. Stop here.
Yeah.
And you begin to talk. Yes, please.
You
This
mean
is fine.
This is fine, right?
Yeah.
Yeah.
Yes,
Then
now it's fine.
I'll start. Okay. In conclusion, it was good. Yes, it was very good. At first, this experiment seemed to be end soon, but it took longer than I'd expected. In parts of experiment planning, experiment preparation, and other partial things. Also, as you can see in this picture, while taking experiments, we had to stay under the blazing sunlight for a long time. The exposure to strong sunlight made us feel harder, but it was the most memorable. As the experiment progressed, we had some measurable problems, such as azimuth angle and the length of shadow. When someone covered a sun with his or her own shadow, the shadow of the figure was hard to see. So we had to be careful not to cover the sun. When putting a protector or ruler against the globe, I was careful not to mess up the experimental equipment. This is because the figure should be placed and measured with the globe be tilted and aligned with the North Pole. As you can see in this picture, in some cases, it was hard to measure because the figure was under the shade of a globe from the beginning. Despite all, it was fun to record and organize the results of the experiment. Linking the results of the experiment with what I already knew is especially good for me. How the time of the day affects shadows is the most interesting part of all. Lastly, what I want to say is, I was very happy that I did participate in this project. Thank you for listening.
Thank you very much. You present a very good activity with your colleagues. How many students are you in the group? The number of students. How many students are you in your class?
Okay. I remember the students maybe seven students.
7. Very good. It's a nice group. It's very good in order to work. Yes, excellent. Thank you very much. Congratulations for your presentation. Thank you. Victor, the next one speaker is one speaker from Indonesia.
Yeah.
Is
Josephine.
Josephine Maria Gwindayanti. Probably I pronounced very bad. Josephine,
Oh yeah.
you were
Hello.
before with us. I remember to see you. Okay. Excellent. Thank you, Maria. Josephine, sorry. Okay. Then I would like to listen your presentation
Okay.
when you want.
I will present with PowerPoint.
Yeah, if you want.
Oh, Wait a minute. Sorry. Chrome. Okay. Can you see my presentation? Hello.
Not yet.
No.
Not yet. Uh-oh. Yeah. Oh, I can share my screen.
Well, if you want, you explain to us what you're doing. And Victor will use one slide that I prepare with you and your students. This is the slide that I prepare for you. And if you want, you can comment what you are doing with your students using this slide, okay?
Okay. Yes. Let me introduce myself. My name is Josephine. I'm teach physics at Santa Maria Catholic High School, Malang, Indonesia. Since 2016, I have always participated in program organized by NASE by carrying out a simple astronomical experiment with my student. First of all, I will introduce the location of Indonesia. Our country is an archipelago located around the equator. Indonesia is on 6 degrees north latitude until 11 degrees south latitude and 95 degrees until 141 degrees east longitude. And this is my experiment with my student in our school. Now, our school is located at 7.98 degrees at south latitude and 112.61 east longitude. First of all, I want to answer the question asked by Professor Rosa for the purposes of this meeting. The question is the parallel Earth useful in the curricula of your student in Indonesia? I try to answer this question. In the national curriculum of Indonesia, the senior high school level doesn't get
very short. Only 1 minute, please. Only 1 minute.
Yes.
Very short,
Okay.
Josephine.
Yeah.
Thank you.
The senior high school level doesn't get astronomy material, so I only explain astronomy material to students who are member of physics and astronomy club, which are the extracurricular material in my school. For the junior high school level curriculum, there is the material about the solar system in grade 9. In my opinion, the parallel Earth experiment will be very useful for learning material on the solar system, because through the experiment, teacher can explain how the season on planet Earth occur. So far, the weakness that exists in the learning process in Indonesian curriculum is the lack of practical activities. So students tend to only learn the theories taught by the teacher and memorize them. As a result, the student quickly forgot the learning material they got. With my experiment, while carrying out the parallel experiment, then I explained to some of my students who participated in the experiment. They just really understood how the season changes according to the position of the sun at a latitude that changes throughout the year in the various places on our Earth. With his experience carrying out this experience, I have the task of being able to disseminate the result of this experiment to junior high school teacher. Yeah, you
Okay.
can see
Thank you.
maybe this is some photograph of my experiment. We are doing this at June 21,
Yes,
2020.
thank you very much,
There's a
Josephine.
small solstice. Yeah.
Thank you. I would like to show
Thank
you this picture is perfect in order to observe that in the
Yeah.
North Pole we have sun because it's the summer solstice, and in the south it was a night. It was a very beautiful picture.
Yeah.
Well, thank you very much, Josephine. We don't have time for questions. I'm
Yeah,
going
you're
to use the
welcome.
next one. Thank you. The next one speaker is Chia Ros Sia from the Philippine Normal University. Please, I would like to, Chia, I see you. Well, I would like
Hello.
you introduce on what the parallel Earth, and especially the problem that you have in order to prepare your experiment. Thank you.
Yes, thank you very much. Good morning, good afternoon to everyone. I am Sheila Rosia from the Philippines, currently affiliated with Philippine Normal University. We are located we are a Southeast Asian country. Can you see my presentation? Are you able to see this? Sorry.
Yeah.
Okay, so the Philippines is located near the equator from 4 degrees until about 20 degrees north latitude, and where I took my pictures is about 14 degrees north latitude. These pictures were taken just for so that I will have materials for my lessons in time. I had the opportunity to join the NASE that was held in Japan and got to know Rosa and the others. So here are my pictures that was taken. I was able to take pictures on June 21 and also on September 21. So these were my pictures on June 21. Shadows are not that visible because we usually have cloudy days, but this one is the one that are better pictures. Then for September 21, I had the opportunity to do it 3 times for that day. Because I have the problem here is usually in the afternoon, especially during September, we have cloudy afternoons and a lot of thunderstorms. Therefore, taking pictures at the same time at different days is a little bit hard. I was hoping to take pictures at around 12 noon. Unfortunately, I did not have that chance because cloudy skies were evident during that time. Luckily, at around 12:30, there were enough sunlight to create the terminator on my globe, on my activity. Here are other pictures of it showing different times. This helps me to show my students that changes in the terminator, when will it be daytime or nighttime in different places, and how it is affecting the shadows that we are forming every time. So this is my comparison for the summer solstice and the autumn equinox, visibly showing the amount of sunlight received in the northern hemisphere since the Philippines is in the northern hemisphere. And this was the activity that I did with my students back in February, wherein they, just like what the student has shared from South Korea earlier, they were having a hard time staying under the sun for a long time. That is it. Thank you very much.
Thank you very much, Sia. And I don't know if there are any questions in the chat, Victor.
Well, it's a comment. Tomita has said that it's a good strategy to drawing lines on the photos, and he will do it the next time.
Yeah. I was not able to put on the marks for the Terminator. That is why. Thank you very much.
Thank you. It was a very nice presentation. And the next one, the speaker is Margarita Metaxa, that I think is in Greece with head students. Is from the High School of Tositseio Arsakeio Ekalis. I don't know what I pronounce badly, sure. Margarita, and your students? Yes.
We're your students.
We don't have the opportunity to see your faces, please, with your video camera.
Can you not see us? We have opened our camera, but I think there's a problem. So, can you hear us?
Yeah.
We hear you very well, don't worry.
Okay.
Do you have a PowerPoint to share with us?
Yes, we do.
Yes.
Trying.
But I want the compromise that you take a picture of you and your students and to email to me, okay?
Can you see the PowerPoint?
Not yet.
No.
Rosa, you can't see our PowerPoint?
Not yet.
No.
No. Can you help us, give us some instruction how we can put it on the screen?
Yes, you have to go to the right part and you have information about to share now with us. And you put over there.
Winner?
And then you open one window or the comfort screen.
So we are going down and we see some options, but maybe the one that says start presentation. We can't.
There are one signal, and on the right, absolutely on the right, there are 3 points. No, 3 points, before.
Yes.
Little,
Yes.
a little. Yes. Then it's sharp. Now you put there, and after you have 2 possibilities: all the full screen or only one window.
Yes. And then?
And then you take one of them, for instance, the full screen, maybe it's easier.
We have choose full screen, yes. And
yes, and then you have to see one small window where appears that different PowerPoints, your PowerPoint and the full screen, and you have to put on the PowerPoint.
Δεν το ενεργοποίησες. Δεν έχεις αυτό εδώ κάνεις το PowerPoint. Δεν το ενεργοποίησες.
Μήπως από εδώ.
Όχι, δεν γίνεται από εδώ.
Αυτό
Αυτό είναι...
να πατήσει κανονικά αν κάνεις την παρουσίαση.
Margarita, I suggest that you explain to us your
Yes, I will.
experience because the PowerPoint is difficult. Okay?
Okay, it seems like we can't share our PowerPoint.
You speak very well English and you are a Mediterranean person and you speak very well, I am sure. You can speak to us and
Okay,
explain.
so oh, now do you see?
No.
Now I
No,
think
no.
No.
Oh,
This
no.
is a picture that show your picture that you sent to me, okay?
okay. So
Okay.
my students can start with their presentation without the PowerPoint, unfortunately. Δεν είναι μέσα.
But could you explain your experience? And I would like that you invite some of your students to tell us their opinion.
Άμα βγει τώρα και το ξαναπροσπαθήσουμε.
Τι?
Άμα βγει η κυρία και το ξαναπροσπαθήσουμε.
Rosa, do you think that we can start our presentation after you can start with the next presentation, so to try to find a way?
Now, we have a break now.
Okay.
And then we have one after the other one. I suggest that the best is that you explain a little bit and introduce your students and they say to us some feelings about the experience and all of this.
Ολόκληρη στην οθόνη.
Είναι χρήση τώρα.
Παιδιά, κάτι δεν μας επιτρέπει από το πρόγραμμα. Αρχίστε τώρα να λέτε εσείς. Good morning.
Good morning. You can hear us. Okay. So about the program. The Earth, as part of the solar system, has certain characteristics which affect our daily life, such as the alternation of day and night and that of the seasons. They are related to the movement of the Earth around the Sun and itself. However, this correlation is not easily perceived, since we are part of the system ourselves and the system evolves at a scale that is too large for our size in space and time. So in the framework of this program, via an easy strategy, the study of the phenomena of day and night, as well as that of the seasons, became a reality. So the strategy proposed by the program is based on the fact that if we have two globes placed in such a way that the rotating axes are looking at the same direction, then the same source of light illuminates them at exactly the same locations. So in order to observe its phenomenon, we use the globe as the Earth, knowing that when it's placed appropriately, the sun will illuminate it as it does the Earth at any given moment during the day. So this is the procedure we followed for each proposition of the experiment. The first step was removing the bases of the globe and placing it on a glass so that we can orient it as we wish. Then we place the protractor on the equinox as it is defined on the globe and turn it 23.5 degrees to the right so that its rotating axis has the same incline as the Earth. Then, with a compass, we oriented the highest point of the rotating axis towards the north. In order to ensure that the area in question was at the highest point of the globe, we attempted to balance a pen on the location of Greece on the globe. And it was necessary to move it slightly in view of balancing the pen. But once we had done so, we knew the orientation of the globe was correct. And then, having positioned the globe as precisely as possible, we charted the initial shading line of the sun with pieces of plasticine. So, about the observations on the day and night alternation, it's well known that the phenomenon of day and night is attributed to the Earth's rotation on its axis. Every time a part of the Earth is lit, it's in daytime, while the part which is not is in nighttime. So we initiated the study at daytime, and as the hours went by, the shading line of the sun moved to the west, and when it surpassed Greece's location and the sun stopped lighting the globe, it was indeed nighttime. And about the observations on the seasons, in this case, the differences were not observed after each repetition because they were not visible in the course of the day. On June 8th, when the experiment first took place, a few days before the summer solstice, it was spring in the northern hemisphere, not only in the south hemisphere. So we observed that the sun mainly illuminated the northern hemisphere. And on September 29th, just days after the autumn equinox, the solar disk equally illuminated the two hemispheres. So based on our observations, we can predict that during the winter solstice on December 21st, the sun will mostly lighten the southern hemisphere rather than the northern. So about our feelings about the program, through our participation in the program Parallel Earth What's the Season, we acquired a better understanding of certain features of our daily life which we did not fully comprehend before. We might have been aware of the phenomenon of the seasons in theory, yet the proposed strategy of the program enabled us to learn certain facts about it in practice, as if we could actually see the Earth from the sun. So it was a very rewarding opportunity for us to acquire important knowledge. So now we
Well,
would like,
thank you very much. Margarita was a very good student. I am sure that he prepared very well. And I would like to suggest that you take a picture of your students and you and email me. And after the next session will be at 11. And I put in order that all the participants can see your questions. Okay?
We have.
Can we answer the
We
question?
have
Rosa, excuse me. We have 1 minute just to explain about the question you had put us. About
yes, but it is very late. It is 54 and we begin at 11. And I need to give to the people some minutes to rest, okay? And don't worry, next time you could do it. And thank you very much. And I would like that at 11, all of you participate again, because I would like to take a picture of the group, of all the participants with your video, okay? At 11, please. And now we have a break, only 6-7 minutes, no more. Thank you very much. Quin altre? Vale. Well, hello again. I changed my computer, sorry. I have serious problem because I don't have light in my house. And then it is a crazy situation, but you know, the Murphy's law never falls. Then I would like to take the picture of all of you, okay? And after Karma begins to introduce her presentation, okay? Then I will take several pictures of different screens because I think that you are a lot of people. And I would like to take the picture now with you.
Excuse me, could we please answer our question?
Sorry?
And then our presentation.
Yes, okay, Margarita, but only 2 minutes, please.
Okay. It's 1 minute. Do you believe that the parallel Earth could be useful in light pollution? Light pollution is the presence of artificial light in otherwise dark conditions in night. The term is most commonly used in relation to the outer environment. Adverse consequences are multiple. Light pollution competes with starlight in the night sky for urban residents, interferes with astronomical observatories, and like any other form of pollution, disrupts ecosystems and has adverse health effects. But probably in our everyday life, especially in urban areas, people, students, don't realize the loss of the night as a side effect of industrial civilization and mostly its necessity. So yes, the Parallel Earth project introducing the necessity of the natural alteration of day-night and indirectly can be an introduction to the light pollution problem. So that's all.
Oh, thank you very much. But I would like to invite you to take the picture with your students and to mentor me, okay?
Okay.
Thank you, Margarita. I am sorry that to have so difficulties to contact with you and to see you.
We are.
Thank you. Bye-bye.
Bye.
And then we begin now with the presentation of Karma.
Hola.
Please, Victor, could you? Okay, excellent.
Yeah, I'm sharing my presentation, the Karma's presentation. Yeah.
Sí.
Okay. So.
Karma Alemán is a retired professor or retired teacher at a primary school in Santa Eulalia de Riu Primer. This is a small city close to Barcelona. And she has a lot of years experience with primary school students. And the presentation will be related to primary school students of Roure Gros, that in the small village that I mentioned before. Thank you, Karma.
Gracias. Hola, buenos días. En primer lugar, voy a pedir disculpas porque no puedo hablar bien en la lengua inglesa y por lo tanto lo voy a hacer en español.
Yes.
Y Víctor amablemente se ha ofrecido en traducirme. Gracias.
Yes. First of all, I want to apologize because I don't know how to speak English, and then, okay, I'm Victor, I will be translating in Karma.
Thank you. Yo voy a presentar la presentación que voy a hacer. Va a ser centrada principalmente en el trabajo que hemos hecho con la Tierra Paralela en la escuela Roure Gros de Santa Eulàlia de Riu Primer, que es un pequeño pueblo de Cataluña, donde la astronomía ha sido desde hace muchísimos años centro de todo el aprendizaje globalizado en la escuela.
Okay, so I will present our work that we do at Santa Eulàlia, that is a small village near Barcelona, where astronomy always has been like a center of a global teaching practice.
Conocimos el modelo de tierra paralela a través de escritos y alguna conferencia de Nicoleta Lanciano, que antes ha hablado.
We knew this model, this Earth Parallel model, thanks to Nicoleta Lanciano.
Y bueno, enseguida vimos que esto era una gran posibilidad para comprender cuáles eran los efectos de los movimientos de rotación y traslación de la Tierra.
And we use this model to understand the rotation and translation movements.
Pots passar, Víctor, sisplau. Primeramente nos vimos con la necesidad de que los niños comprendieran que aquello no era un modelo imaginario, que respondía a una realidad. Entonces,
First of all, we need that students understand that their parallel model were a real model and not an imaginary thing, a real model.
Partimos de la idea de si nos elevábamos desde el patio de la escuela perpendicularmente hacia el espacio, cómo podríamos ir viendo la Tierra cada vez más grande, más grande, más grande, hasta verla de un tamaño que era posible verla toda, en toda su parte superior.
Okay, so we start explaining the Earth parallel like a journey, like a journey that we made in a perpendicular way into space. So there is a point that we will finally see the Earth as a small sphere.
Subimos a lo alto de un monte, subimos en distintas alturas. Algunos niños habían ido en avión y podían realmente relacionar el hecho de que al subir perpendicularmente podíamos ir viendo la Tierra cada vez más pequeña.
And thanks to that we went to a mountain, and other children that went on a plane. Then the children link this idea that if we goes in a perpendicular way into space, then we see the Earth. We can see the Earth as a small sphere.
Pero esto no era posible, subir en cohete no era posible, por lo tanto, lo que hicimos era pensar cómo podíamos ver la Tierra así de pequeña y empezamos a pensar en la construcción de este modelo, del modelo de tierra paralela.
Okay, so we thought about how it could be possible to see the Earth as a sphere, and then it's that way that we start to think about the Earth parallel.
¿Pasas, Víctor? A través de distintos modelos, por ejemplo, con estas dos pelotas, estas dos esferas, fuimos viendo que al moverlas conjuntamente, los efectos de luz y sombra se producían exactamente igual en la pelota pequeña que en la grande.
Okay, so we use two balls, two spheres, and then we see that the movements and the shadows were equal in the small ball and the big ball.
Así pues, si colocábamos nuestra tierra paralela a una tierra colocada de la misma forma que está colocada la Tierra de verdad, el planeta Tierra,
Okay,
si lo poníamos...
If we place our model as the same place of our Earth,
situada en la misma posición, veríamos nuestro planeta desde lo alto. Nuestra Tierra paralela girará conjuntamente con el planeta y en él podemos ver los fenómenos de luz y sombra derivados de la luz del Sol y sus propios movimientos, tal como sucede en la Tierra.
So our parallel Earth will revolve together with a planet, and we can see the phenomena of light and shadow derived from the light of the sun and its own movements just on the Earth.
Pasa, Víctor.
Sí.
Nosotros nos planteamos que las tierras que teníamos, las esferas de tierra que teníamos eran muy pequeñas y para los niños y también para los adultos era difícil poder ver estos efectos en una esfera tan pequeña.
Okay.
Por lo tanto...
At first, our spheres, our Earth spheres were too little, and it was difficult that the students see these effects on these small spheres.
Nosotros en la escuela nos planteamos construir nuestra propia maqueta de la esfera. a partir de una esfera de
So,
80 centímetros de
yes,
diámetro.
and because of that, we plan to build our model from a sphere of 80 centimeters in diameter.
Esta aventura empezó hace 20 años y con el grupo de niños de 10, 11 años empezamos a dibujar sobre la esfera los meridianos, uno cada 5 grados, y los paralelos, uno cada 15 grados.
Okay, this activity started 20 years ago, and with 11, 12 years old students, we start by drawing the meridians, one every 5 degrees, and the parallels, one every 15 degrees.
Aprovechamos este trabajo como un mayor conocimiento de lo que es una esfera, un conocimiento de lo que son las redes que nos permiten situar un punto en una esfera. O sea, la idea de latitud y longitud fue como una idea muy profunda de conocimiento de los niños.
Okay, and at first we had clear that the ideas of latitude and longitude were essential in order to understand this model.
A partir de un mapa estuvimos buscando la latitud y la longitud de los puntos más sobresalientes del contorno de los continentes y los situamos en la red que estaba dibujada sobre la esfera. Y así obtuvimos el contorno de los continentes.
So we look for the latitude and longitude of the most prominent points, and this is how we obtain the contour of the continents.
Pintamos el interior de los continentes partiendo de un mapa satélite donde podíamos observar las zonas climáticas más relevantes.
We paint the interior of the continent using a map, and thanks to that, we could observe the most relevant climatic zones.
Y usamos la técnica del puntillismo utilizando más espesor de la pintura, de forma que se podía percibir un cierto relieve al pasar la mano y así poder distinguir con el tacto los continentes de los océanos, pensando en facilitar la percepción a personas con dificultades de visión.
Yes, and we use the pointillist technique because we want to give a certain relief to our model, to our sphere, because by this way, by touching, we can distinguish the continents from the oceans.
Con esta esfera y situando el modelo en estación con el eje en dirección norte-sur y el lugar donde observábamos paralelo al suelo y colocándolo en un lugar soleado, podíamos observar los efectos, puedes pasar, los efectos del movimiento de rotación de la Tierra, el día y la noche, y los efectos del movimiento de traslación, las estaciones a lo largo del año.
Okay, so with this parallel Earth model located in a season and with the axis in the north-south direction in the place from where we observe parallel to the ground, and place it in a sunny place, this is important. By this way, we can observe these two movements, the effects of Earth rotational movement, day night, and the effects of translation movement, the seasons throughout the year.
Algunas zonas vimos a través del movimiento de rotación como algunas zonas están iluminadas por el sol y otras no. Unas zonas es de día, otras es de noche. Y si colocábamos un testimonio, como estas líneas que se ven de plastilina, un testimonio en el lugar donde pasaba la línea separadora del día y la noche, podíamos ver, si salíamos al cabo de una hora, podíamos ver cómo la línea se había movido 15 grados.
Okay, so we are going to talk about rotational movement, and as well as you know, some areas are illuminated by the sun and others are not. So if we place some testimonies in the place where the line of separation of the day and the night is, and we observe after an hour, we can see how it has moved just 15 degrees.
Podíamos ver que este movimiento, si lo veíamos a lo largo de varias horas, podíamos ver cómo este movimiento era constante. Por lo tanto, Sabiendo esto, podíamos saber la hora que era en cualquier lugar de la Tierra.
Okay, and if we observe this effect constantly, we were able to see how we were able to predict the solar time of any point of the Earth.
A través de la Tierra paralela podíamos comprender qué pasaba con el movimiento de traslación. Podíamos observar a lo largo de un año cómo las sombras iban moviéndose, pasando en los equinoccios. La línea que separa la luz de la sombra pasaba exactamente por el eje.
Okay, using the translation movement, we can deduce first the seasons, and then how we can deduce also, we can observe how the shadow that separates day from night passes exactly along the Earth's axis of rotation.
¿Pasas la otra?
Sí.
Cuando es invierno en el hemisferio norte, vemos cómo no llega la luz del sol al polo norte. Vemos también que la duración de los días es mucho más corta y como hay muchas menos horas de sol. La temperatura es inferior y hace mucho más frío.
Okay, when it's winter in the northern hemisphere, we see how the sunlight does not reach the North Pole. So consequently, the length of the days is much shorter and there are far fewer hours of sunshine, the temperature is lower and it's much colder.
Además, el sol se mueve más bajo y sobre el horizonte real, así los rayos de sol inciden sobre nosotros mucho más inclinados y la sensación de calor sobre la piel es inferior.
So, in addition, the sun moves lower over the real horizon and then the feeling of warmth on our skin is lower.
Esto podíamos percibirlo sobre el modelo solamente pasando la mano en las distintas zonas de la Tierra.
And this sensation can be perceived by passing your hand over the model in some areas of Earth.
Si colocamos unos pequeños gnomons a lo largo de un mismo meridiano, podemos observar la evolución de las sombras en distintos lugares de la Tierra, a distintas horas. Las sombras que producen todos los gnomons en un mismo momento están todas en un mismo sentido, pero en direcciones diferentes según la latitud del lugar. Y las sombras al mediodía señalan la dirección del meridiano.
Okay, if we use nomos, we can place these gnomons along the same meridian, and then we can observe the evolution of the shadows in different places of Earth and different times and in different seasons. The shadows produced by all the nomos at the same time are all in the same direction, but in different directions according to the latitude of the place. The shadows at noon indicate the direction of the meridian, and the shadows of the nomos near the pole are longer.
Si colocamos pequeños gnomons a lo largo de un mismo paralelo, podemos observar que las sombras a lo largo del día van de oeste a este, pasando por el norte al mediodía, si estamos en el hemisferio norte. Si estamos en el hemisferio sur, al mediodía las sombras pasan por el sur.
Okay, if we place small gnomons along the same parallel, we can observe that the shadows throughout the day go from west to east, passing through the north at midday, if we are in the northern hemisphere. If we are in the southern hemisphere, at noon, the shadows pass through the south.
Pasa. Asimismo, la sombra podíamos ver a través de sombras de pequeños muñecos como el muñeco de la derecha de la foto señala hacia el norte, porque allí es mediodía. El que está a la izquierda señala hacia el oeste, porque allí es por la mañana. Y las sombras de los muñecos que se ven en la parte superior de la fotografía irían hacia el este, porque es por la tarde, o son inexistentes porque se ha hecho de noche.
The shadow of the small dummy on the right of the photo points to the north, because it's noon there. The shadow of the doll on the left points to the west, because there it's morning. And the shadow of the dolls that are seen in the upper part of the photo will go towards the earth because it's in the afternoon, or they are non-existent because it has become night.
Pasa. Este modelo nos permite a las personas con dificultades visuales, sencillamente pasando la mano por la superficie, percibir el diferencial de temperatura provocado por la incidencia de los rayos solares en las distintas zonas de la Tierra. Permite también distinguir los océanos de los continentes. Es un modelo que puede integrar a personas con muchas dificultades de visión a niños, por ejemplo, ciegos que a veces hay en la escuela.
This model has a clear advantage because it allows people with visual difficulties simply by passing their hand over the surface to perceive the temperature differential caused by the incidence of the sun's rays in different areas of the Earth. And it also enables them to distinguish between the oceans and the continents. So this model is indicating especially for blinded students or for people in general with visual difficulties.
Pero vimos como muy importante este modelo para globalizar muchísimos conocimientos, principalmente en qué incide todo este movimiento, toda esta relación del movimiento de traslación y de rotación de la Tierra, en qué incide en la vida de las personas, de los animales y de las plantas. Uno de los trabajos que hicimos fue imaginar personajes que viven en distintos lugares de la Tierra y pensar qué podían estar haciendo en un mismo momento. A partir de estos personajes pudimos hablar sobre los lugares en que viven, sobre sus costumbres, sus rasgos culturales, su forma de vida, el clima, la vegetación, la fauna, la gastronomía, su ropa, sus vestidos, sus casas, y pensar cómo influyen estos fenómenos derivados de estos movimientos en toda la vida de las personas.
Okay, by using this model, we can think about how these phenomena of the rotation and translation movements influence on the Earth. So with the students, we did a little activity that consisted on imagine different characters living in different places on Earth and think what they might be doing at the same time. And thanks to these characters, we can talk about the places where they live, their costumes, their cultural features, their gastronomy. So using this model, we can know and we can learn about people around the world.
También pudimos situar sobre la esfera algunas fotos de paisajes en el lugar al que pertenecen y así formar un mosaico que relacione la situación con su clima, su población, su forma de vida, sus casas. En esto nos ayudó mucho el libro de fotografías de la Tierra desde el aire de Arthur Bertrand. Escaneábamos estas fotografías, hablábamos sobre a qué lugar podían pertenecer, sin necesidad de que los niños o todos tuviéramos que saber exactamente el lugar. Era importante saber las características de este lugar, aunque no fuera el lugar exacto. A partir de aquí buscábamos exactamente de dónde era esta fotografía y la pegábamos encima de la esfera. De esta forma conseguíamos como un mosaico de distintos paisajes que nos configuraban un poco la idea de cómo se vivía en estas zonas de la Tierra.
Okay. For doing this activity, we were really helped by this book, by a book of Arthur Bertrand, and we scanned photos, and then we have to try to know where these photos, the place where these photos were taken. So then we place these pictures on the Earth model, on the Earth parallel model, and by looking at these pictures, then we can know about the situation to the climate, the population, their way of life, their houses. And definitely is by using some pictures, we can know about people in different places and their situation, their way of life, their fauna, and all this stuff.
Y con los más pequeños los situábamos pequeñas fotografías de animales. Las podíamos relacionar su disposición con el clima, cómo era su pelaje, cuáles vivían unos con otros, la relación entre ellos, la relación entre los animales y las personas que vivían en esta zona. Los pequeños así también podían comprender más o menos qué relación tenía el clima y la situación de la Tierra con los animales que la habitaban.
Okay, and with the little studies, we place small pictures of animals, And we can relate their disposition to the climate, vegetation, and environment of the place where they live. By putting these small pictures of animals, then we learn about, well, the climate, the way that they relationate with humans, and all this.
Y con el modelo de la Tierra paralela, podíamos hacernos una imagen más global de nuestro planeta. Nos da un punto de inicio para intentar conocer la vida en los lugares de procedencia de niños que en este momento habitan nuestras escuelas. Es un modelo totalmente globalizador de los aprendizajes. Nos permite ver la realidad en todo su conjunto, sin parcelaciones, las situaciones interdependientes dentro de un mundo natural y social, y trabajar el valor de la diversidad como la gran riqueza que nos ofrece vivir en nuestro planeta.
So, as a conclusion, the Earth parallel model is useful to make us a more global image of our planet, because using this model, our children, for example, can meet it gives us a starting point for trying to learn about life in the places where the children who live in our schools come from. And definitely it's a totally globalizing model of learning, because it allows us to see reality as a whole without parceling it up, the interdependent situations within the natural and social world, and to work on the value of diversity as a great wealth that living on our planet offers us. And Karma, I think that, yes, we have finished, no?
Yeah. Sí, ya finished. Thank you. Thank you.
Thank you, Karma. We have one comment and one question. I would like to ask to the people that try to explain in a short way. Okay, the comment is Nicoleta that want to introduce a comment to your presentation.
I think it's very, very important to work with a very big globe with children. Very important. But I have another suggestion, to be more carefully with, to pay attention to the generalization about direction of shadows. It's very complicated, because in the tropical zone, you have different situations, not like in the north or in the south, but like in the north and in the south. So be careful with generalization about direction of shadows, only this.
Thank you, Nicoleta. Carlos Moreno, do you want to ask a question? You say to me, Carlos.
Muy breve, bueno, te lo hago, Carmen, en español, muy conciso y muy concreto. Gracias por la presentación. Te conocí hace unos años en Madrid, cambiaste nuestra visión también de la educación o ayudaste a cambiarla, y mi pregunta es, dame un argumento muy potente para conseguir transmitir y contagiar como tú la importancia del aprendizaje globalizado en proyectos, y que los profesores en primaria no estén tan obsesionados con sus currículums.
Bueno,
I want to translate a little bit.
Yes, better.
Victor, you translate better than me.
Yes. Carlos is asking to Karma Alemany for a reason or for a question. Yes. Why Karma Alemany has to give a reason of the importance of the globalized teaching to the little students.
Bueno, yo puedo dar un argumento que ha regido el equipo de la escuela principalmente, con un gran acuerdo, y es que la realidad no está parcelada. La realidad es compleja y la realidad necesita de la interacción para poderla conocer. Yo les decía a mis compañeros, si salimos y vamos a ver un árbol, no podemos ver un día el árbol desde el punto de vista biológico, otro día desde el punto de vista poético, otro día desde el punto de vista artístico, sino que el árbol es un árbol. Entonces, la sensación de que para poder entender el mundo hace falta conocerlo, verlo desde toda su complejidad. Y además no hay edades para comprender cosas. O sea, la globalidad se comprende a través de las interacciones y no parcelando a los 3 años, a los 5 años, a los 12 años, porque esto no relaciona conocimientos.
Okay. Here in our school, we have very clear that we have to understand the reality as a whole. We cannot parcel the reality, and well, we need to teach the interactions between all the elements that are or that form our reality. We cannot parcel it and this is because, and because of that, we consider that the teaching in a globalized world is very important.
Gracias, Carlos.
Thank you very much, but we want to begin with the next one speaker. The next one is Mahdi Rokni from Iran Teachers Astronomy Union, ITAU. Mahdi, it's your turn.
Thank you. Can you hear me?
Yes, very well.
I want to present a file if I can.
Yes, you try to use a PowerPoint also?
Yes, I have a PowerPoint to show.
Yes. Okay,
Thank
you
you.
try to share with us.
Can you see the PowerPoint?
No.
Yes.
No. Yes.
Thank you. Thank you so much, Rosa, for this opportunity. And I want to thank all of the people who participated in this project and give us their undying support. In ITAU, we aim to teach students life skills, and we were delighted to be able to participate in this project. We started this project with training our team, and after that, all of our members were able to do this project by their own without any help. And when we carry out this project with teenager students, younger students and children encouraged to participate in this project. And when they come to the project, the meaning and the beauty of the project became greater. As you can see, we do this project for children near one of our historical places in the city in the Equinox Day, and I think it was a very perfect day for do this with children, and it was a great opportunity and great experience for them. They came with their families and parents, and it was interesting that parents had a big role in this project with helping and cooperating with children and with us. So you can see we started this project with shadow experiment. We asked children to look at their shadow in the morning, that they could see their long shadows in the morning. Then we asked them to look at the parallel earth and see the shadows on it. And we asked them to try to find a place with the smallest shadow on the earth. So they could find a place that doesn't have any shadow, a place, a shadowless place in the earth, and they memorize this place and remember that. After that, we came back at noon and tried the same thing again. We asked children to look at their shadow again, and it was a big surprise for them because now they could see a big difference between the first shadow in the morning and the second shadow, and they could understand the changing of angle of the sun. After that, we asked them again to look at the parallel earth and try to find a new place without any shadow. And they could see that the first place has been changed, and the second place, it's another place that doesn't have any shadow. And it's because of changing the angle of sun and turning around for the Earth. So, but the most important thing after this project was we asked them to go home, and the day after that send us their reactions, their comments, their feedback, however they like. For example, some of them send us some paintings, and they paint the experience and show us by the pictures and the colors. Or they send us some videos and speaking about their experience with their own words and explain the project and this experience. I will send to the conference and all of you a complete video about that. We also share these photos and videos in the social media and websites for other children and families, so we can encourage them to join this project or any other project that will come. And finally, I just want to ask Safia to come here. She's a NASA instructor, and she was a big help for us. She worked with kids, and she helped us to do this project with kids. And I think without her, we couldn't do this project, because it is a very, very hard work to work with children, this kind of projects.
Mahdi, I'm sorry, but you are finished your time. But
yes, I'm finished. Thank you. I'm finished.
Okay, thank you. Thank you very much. Do you want to be all of your colleagues with you in order that you know them?
Yes.
Hello, Akram. Hello. Hello. Congratulations for your team. Okay. Bye bye. See you.
My team.
Bye bye.
Bye bye. Thank you.
Okay, the next speaker is Jibaji Norali from the Open University of Tanzania. I want to thank especially Jibaji his help in order to use different language in Africa. He's translating to Swahili. And I think it is a very important thing for NACE. It is important that we use different languages and also language from Africa. Then, Jibaji, when you want, you can begin.
Thank you very much, Rosa. I appreciate very much.
Mahdi, could you finish your PowerPoint? You share the PowerPoint and we cannot share other ones. Mahdi?
No, she's not sharing the PowerPoint.
Ah, no?
Okay, no, she's not sharing. No.
Sorry. Okay, sorry. Okay. Jibaji, when you want, you begin.
Yeah. Okay. Where is my screen? Okay. Thank you very much, everyone. I would like to thank Rosa especially for doing a lot of efforts to get our activities. I am a physics teacher at Marian University College, and I'm an astronomy consultant at the Open University of Tanzania and the NASA coordinator. So I think I have the full screen. Yeah, you can see the full screen?
Yeah, very well.
Yeah, okay. So this is what we are between December last year and June this year. We had two almost first-hand astronomy training, one together with the activities themselves, hands-on, and the other online. But I would like to thank my own coordinators for assisting in this training also together with the NASA trainers. Now, one of the things that I would like to stress is that when we see diagrams about seasons, one of the most confusing things, even if you look at the Wikipedia diagram, even the NASA diagram, it looks like an egg, But the orbit of the Earth is not an egg shape. It is oval, we say, but that is in a very strict sense. So we have to get the idea that it is circular. So we have to remove all these misconceptions also about the distance being affecting the seasons, the distance between Earth and Sun affecting the seasons. So now other problem is that we don't have any experience of snow in winters, for example. I mean, we have only, we don't have 4 seasons here in Tanzania. So we have only 3, in fact, finally, hot, maybe rainy, and cool. And in fact, finally, if you break it all down, it is hot and cool season. So our learning about seasons is often about cramming from books, autumn and spring. They don't make sense for us. So the parallel Earth allowed us to explain now that our teachers, we are giving them the opportunity or the way to explain how seasons occur and how it is always hot in the tropics, in spite of the inclination of the axis. So although the axis of the Earth is inclined, the amount of sun that we get still remains almost the same throughout the year. So we have one of the most important effects that we saw in parallel Earth was that the long shadows that we saw on a globe in different latitudes, they can be related to the cool periods in the evenings or the mornings. So here we see that when the sun is moving from morning till evening and it passes above us, the mornings are cool and the evenings are cool, but the noon is very hot. So we are, in a way, we are demonstrating that it is the shadow, the distribution of the sunlight on a much larger surface that is the reason for the hot and cold periods on Earth. We have had a lot of success with the NASA. The teachers are very excited, and we were able to even do some activity when we distributed 10 telescopes from the Open Astronomy Schools project, where we have been able to get 30 schools to share those 10 telescopes. Thank you very much. Asante-san.
Thank you very much, Jibaji. I don't know if there are any questions for you. I think that there are some comments but not exactly questions for you.
There are some comments. Okay.
If I can, I found very, very interesting the fact that not in all the planet there are 4 seasons, and this is something that we, from our climate, from our position in the globe, with the colonization put in every countries, but it is not like this in a lot of countries. There are not 4 seasons. Thank you.
Thank you very much. Yeah, I appreciate it. It is a very big problem for us. Thank you.
Yeah. For all the countries in the same area, in the equator area. Yes, the next one speaker is Otto Tras from Mabara University of Science and Technology from Kampala. Otto, I didn't, before I saw you, but I don't know, is Otto now here? Otto? Ah, yes.
Hello.
Hello. The pleasure to see you. Do you want to share PowerPoint with us, maybe?
Victor, go ahead and share that screen.
I have stopped sharing. I have stopped sharing my presentation.
You share it.
But you have a PowerPoint. Do you have a PowerPoint? No. Okay.
Okay. It's not necessary. You can speak without PowerPoint. Don't worry. It's fine for us.
Okay. So as you can see from the picture, Uganda is an East African country, which is just above Tanzania, as Dr. Jiwaji presented, the previous speaker. So this experiment is very important given that in the country, the curriculum for high school education has been changed and astrophysics has been incorporated in it. And given that astronomy in this country is not so intense, especially in lower high school, NASE and this experiment is very important for the teachers to understand how to incorporate the new curriculum. So with this, since we were in a lockdown, this experiment, we performed it on 16th of September. And I had a number of friends who are teachers. Some of them were teaching geography, others teach physics and mathematics. So they had a number of questions, as Rosa asked whether I had a number of friends or other people I performed this experiment with. The answer is yes. Then they had a number of questions. In other words, a number of misconceptions about astronomy, about the Earth. One of them is that if the Earth is spherical, why don't the people in South Africa fall off? Because when you look at the globe, the South African people, it is as if they are facing downward. So this experiment helped to explain that however much the Earth is spherical, there is a force of gravity which pulls towards the center, which holds everything, including the water in this ocean, that would actually fall off. But that cannot happen because of gravity. So that was cleared. Then they were also confused whether it is always dark or always sun shining in the whole world at the same time. That one was also cleared, that since the Earth is rotating and at the same time translating around the sun, different places face the sun at different times, which means they have different times of darkness and times of light. For example, at the moment right now in Uganda, it is 10 minutes to 1 in the afternoon. But in India, I suppose, which is 2.5 hours ahead of Uganda, it is coming to early afternoon, like going towards evening. So all that was cleared. Then some had questions like whether the Earth, the Moon, and the Sun, whether the Earth is bigger than the Moon and the Sun. That was explained as well, that the Sun is actually much, much bigger than the Moon and the Sun, but it appears small simply because it is very far away, approximately 1.5 million kilometers away from Earth. So that was explained. And also when they look in the sky, they look at the Moon and the Sun being the same size. It is simply because of the distance between the Sun and the Earth and the Moon as well. So that relative distance is the one which creates the perspective that makes them look to be the same size, yet they are not. So all that was cleared, and they also asked whether the Sun is a star. Yes, that was answered. The Earth, the Sun is a star, and it is the closest star to the Earth. And they had also questions about the light of the moon, where it comes from, whether the moon actually produces the light. That is not, the moon does not produce the light. It is just a reflection from the sun. And that is why in the night, even if the moon is there, it is always cold. So all that was cleared. So this experiment was very important, and the NASE teachings are very, very important. And fortunately, I happen to be an instructor of NASE in Uganda, and we are going to continue training more teachers who are in the field and those who are coming, to make sure that astronomy is well understood in the country, given that it has been incorporated in the new curriculum of the country. Thank you very much.
The microphone, Rosa. Rosa, we cannot listen to you.
Sorry. I said that thank you very much to Otto. I am very happy to have the presentation of several different African countries, because I think this is important for us, and this is important for all the community of NASE and the teachers in general. Then I would like to introduce the next one speaker. This is one speaker from Indonesia. This time was from Serbia, but finally the participant from Serbia cannot be here. They may have one volunteer from Indonesia. Is the name, I am sorry, maybe I don't pronounce it in a good way, but it's Aditya Abdilat Yusuf, and he is member of ITERA, and he wants to speak us how to use parallel Earth and the results obtained. Thank you.
Can you hear me? Hello? Hello? You hear me?
Yeah, now.
Okay, may I use my presentation?
Okay.
Okay. I want to share about the parallel experiment to you. To explain to the student about the time zones in Indonesia. We know that in Indonesia we have three different time zones: the Western, Central, and the Eastern. The first experiment here, we use the two gnomon with the stick here, with the stick, and we use to Lampung here, the first stick, and the second stick is in the Eastern Indonesia, in Jayapura. Nah, okay, we try to experiment in two different times in the one day, so we can see the difference of the shadow of the gnomon here about the different time. Nah, we can see the difference here about the time in 9:10, all in Western Indonesian time. It's about 11:10 in Eastern Indonesian time. You can see the difference of the time zones by looking at the shadow of the stick. The shadow is longer than the Eastern Indonesian time stick. And we use the second experiment when the sun is above the Central Indonesian time, about 11:10. Here, you can see that the sun is creating shadow of these two gnomons in a different way. One is heading towards the west and one heading towards the east. So we know that this experiment we can tell the student about how we can use Gnomon to use the as the timekeeper. So one of my students said about how we can use the parallel Earth experiment to set up the equatorial mounted telescope properly. This is so funny because he has the telescope, so and he doesn't know how to use how to set up the equatorial mounted telescope properly. And then he said to me, "Hey, Mister, if we can share this experiment to the people, we can share the experiment so we can set up the telescope properly." Okay, those are my presentation. So much, but
Aditya, for your presentation. I think the point of view of the telescope is new. My first time that I see. Thank you very much.
thank you.
We are very late. We pass to the next one presentation. The next one is from Sakari Eko from Finland. Sakari is a very good friend that I know him from a lot of years. And he is now in Hetta. Hetta is the small village where he has a summer home, and it is exactly in the Arctic Circle. I mean, he is very far away. I connect with him by Google Meet 2 days ago, and we have serious difficulties. I don't know if now Sakari can connect with us, or in other case, we have the PowerPoint presentation of Sakari. Sakari, I don't know if could you present yourself or Victor present for you? I think that Sakari is not here. Then maybe Victor, could you have the voice also? The
Yes,
PowerPoint? Yes, please.
Yes, I will present.
Yes, please. Sorry, but I can't.
You can listen it.
I didn't listen.
Okay, because I'm listening it, but I don't know if you can.
No, we didn't listen. I don't know what is the problem, but we cannot listen.
Okay, I don't know because.
But you have, I put in the Dropbox the text of Sakari. Could you read?
Okay. Yeah. One moment, please. Okay, I'm going to read. Okay.
I suggest you pass the PowerPoint because he wants that you push. Yes. Passa el PowerPoint. Que passis el PowerPoint a la vegada perquè has d'anar picant.
Sí, espera. Vaig anar un moment. Ho vaig llegint i llavors passo les diapositives. Vale. Llavors, slide 1. In the polar region north of the Arctic Circle, there is a time around midsummer when the sun does not set at all. It is called the time of the midnight sun. It is easy to demonstrate using the parallel Earth method. Okay. The slide 2. One photo does not tell that is taken at solar midnight, but a series of photos visualize the path of the sun in the northern sky. Slide 3. My summer house is in Finnish Lapland, about 2 degrees north of the Arctic Cycle, near a small village called Heta. At the summer solstice, the sun is over 2 degrees over the horizon at midnight. The sun does not set at all in Heta for almost 2 months. Midnight in Heta, the summer solstice. The no moon is at Heta, and we can see the sun illuminating the area. The shadows point to south. What about winter? Well, it is not possible to use the parallel Earth method around midwinter in Heta because the sun does not rise for over a month. The darkness is not total, though. In midday, the light has a wonderful blue color reflecting from the snow. The blue hour in Heta lasts several hours. It is possible to demonstrate the polar night with the parallel Earth method. Using the globe in your latitude at the winter solstice, you will find that the region north of the Arctic Cycle is in shadow. This is maybe the most instructive property of the parallel Earth method. You can see the altitude and azimuth of the sun in the whole illuminated hemisphere. And the aurora. In winter, auroras and moonlight often illuminate the landscape. Thank you. And this is the presentation. It's a pity that we can listen it, but
he was connected at the beginning of the session. I saw him, but probably he lost the connection. It is really difficult because he's very far away, and normally they don't have problems in Finland. It is a country with a very good relation with the technology, but Heta is in the close to the North Pole, that all of us, and it is difficult there. And thank you very much for the wonderful picture of Sakari. And I would like to suggest to you that Sakari is not here, but probably he would like to invite us to visit Finland, and especially this north area. And it is a very, very special trip and a very special opportunity to visit it. And I suggest that we visit. Oh, well, the next one speaker in this case is, one moment that I don't have here my PowerPoint open. The next one is Paula Cis from Romania, is the Collegium National George Banitiu. Paula?
Hello everybody.
Hello, Paula.
Can you hear me?
Yes.
Yeah.
Yes, I am in the classroom now with my students.
Okay.
They are very happy to hear you and your presentations.
Excellent. Then
we are impressed about all the presentations. They were so full of pictures and informations, and everything were very exactly. I want to tell to my students, it's very difficult to judge. I mean, not to judge, to think like an astronaut when you are still here on the Earth. Because you have to see the Earth from outside, and this is only for them, for my students, only with their imagination. In this case, I asked them to think if they would fly away from Earth, from this place, which is our schoolyard, to see the Earth from outside. They would see what? They would see our planet, and they would see our place here in Cluj, Cluj-Napoca, from this latitude. You can see here our latitude, 46 north latitude, and the longitude we have 23 degrees and 35 minutes east. So in our place, can you see this image?
Yes.
We did it with a few kids because we need the distance between them, and only a few came to this workshop, to this activity. But they put their own phones, mobile phones, using it like a compass for north-south direction. And here on the bucket, we put it the Earth, planet Earth, with the axis oriented parallel to north-south from the compass. And here you can see a little stick, vertical, put it on our area, on our place, meaning Cluj-Napoca in Romania. Also, we did another picture with a bigger ball, Here you have the equator and the compass and the axis, north-south axis, trying to imitate our planet axis, the real one. And this little doll, I put it for the place I imagine it would be Cluj-Napoca, Romania. Also, I did some pictures like this, but they are not so good. And the difficult.
We lost the connection, I think.
Yes, yes. She has left.
Sorry.
Yeah.
Yeah, okay. Well, we have to continue. My plan was to have 15 minutes free time, but we are very later than I suggest to continue with the next speaker that it is from Italia, Barbara
Hi.
Carani.
Yes. Well, good morning.
From the higher school, I
Yeah.
don't understand, IESS.
Yes, IESS school. We are in the north of Italy. Hi, everybody. Could you hear me? Yeah. Okay.
I
Now,
make a mistake because I put Malang, and this is a copy-paste mistake. I don't know what is your city, but Malang is not your city.
no, not in Italy. Okay.
Sorry.
Okay.
What is your
Now,
city, please?
Reggio Emilia, near Bologna. Yeah,
Near
in the
Bologna,
north.
okay.
Yeah, between Milan and Bologna.
Very
So,
beautiful. Yes, please.
I'm going to share my screen for my presentation. Okay. Okay. Okay, could you see me? My presentation?
Yeah.
Okay. Okay. So I come from Italy. My school team is composed by 16-year-old students from the IESS High School in Northern Italy. In this video, you can see some phases of the experience they did. And my team worked on the project with passion and motivation after a difficult school year last year due to the lockdown, and that forced us to limit workshops and projects. Earth movements, the instance of the sunlight, and the cycle of the season are themes that always excited students. So they worked with passion and dedication. They used the globe, and they removed its stand and oriented it by inserting a marker in the same direction as the axis of rotation of the Earth, and then put it on a glass. Then they spotted their city, Reggio Emilia, on the globe's surface and placed a pencil on it in balance to reproduce the correct orientation of the Earth. And then they observed the shifting of the shadow in different times of the day. At last, they observed also realized the sun shade line was slowly moving across the surface and the globe as the hours went by. The experience was held on September the 21st, close to the autumn equinox. Students found it very interesting and enjoyed it. They really appreciated the result and enjoyed creating useful material in order to explain their work to students in other classes. I think it has been a good experience after a critical period. Okay.
The micro, Rosa.
Sorry, I said that thank you very much for your presentation.
Thank you, you're welcome.
If we have any questions for you in the chat, I think that we don't have. There are comments from different people. And thank you for your presentation. I would like to ask to all the people that
thank you, Barbara.
PowerPoint.
Thank you, you're welcome.
That they email to me the PowerPoint, because I would like to put in the website as a result of this meeting, of this session. And also I would like to organize, I don't know, in some way, but I plan to prepare a notebook about the summary of all of this, and it will be very interesting for me to have the PowerPoint in order to decide what will be included in the book. Please email to me. Okay. Thank you very much.
Okay. Bye bye.
Susan, are you ready? I saw you before. Susan from Germany.
Yes. Hello.
Okay. Okay. Excellent. Thank
so,
you.
I'm sorry, I do not have a presentation, but I would like to ask to change the view on the Zoom. So I would show some pictures here in my camera, if yeah, you agree. So can you see?
Don't worry, it's not necessary to have a presentation, don't worry.
Yeah.
It's fine.
Yeah. I'm a German teacher of physics and math, and I'm involved in NASA project now since 2018. And I'm talking here from Bonn. It's in the middle west of Germany. So it's about 50 degrees north and 7 degrees east. Yeah, this parallel Earth project is a very useful and fantastic tool to become aware of the relative movement of the sun and its position in the sky during one day and during the year, and to understand the illuminated areas of different parts of our blue planet. So this here, I hope you can see it. Yeah. This is my model. So yeah, exactly. I am here. So we have here the equator, and it's 10, 20, 30, 40, 50. So I put the pin over here. And then now it's like midday, so the sun is over there, and I put the north over there. So we are here. And then, of course, you can talk about a little bit tangents, and we have the spot on the surface. So, yeah, in this picture I made with my little model. You can see it like this?
Yes.
Yeah. So I did it last week, so we have lots of cloudy days here, but then I just catch one day with sun, and you can easily see here it's more or less over the equator, perpendicular. You can see it very well illuminated from one pole to the other. And so it's the equinox, of course. We have the sunrise now at 7 a.m. and the sunset at 7 p.m. And the funny thing, maybe it's that you can see the same on the head of this little doll. And yeah, it means in the season, like the other always say, all the North Pole and the South Pole is illuminated. Also, what you can see with this model is the sun rises first in the eastern parts, eastern countries. In German, we say Morgenland. That means, yeah, like Orient, it's the sun of the morning land, and later on in the western part. Last year, I've been with Rosa. You can see this picture also, I hope. We've been to Mongolia. So
Oh, it's not good focus. You have to put a little bit more close to you. No, 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 no. Close to you. No, no, no.
Like this?
No, no, stop now. No, 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 no. Close to you. Near to you. No, no. Far away from the camera. Now. Now. Now.
Ah, this is good. Okay. So we've been to Mongolia, and Mongolia is, if you look at the globe, it's like 47 degrees north. So I have another pin. I hope you can see it. It's like here, over there. It's Asia. Yeah. And it's more or less, it's a little bit more in the south, but it's more or less the same latitude like Germany. So they also, I checked it, they also have the sunrise at about 7 in the morning and sunset at 7 in the evening, of course in local time. So we've been there in June. There, I have another picture. I hope you can see it like this. Yeah.
I think it's not focused also.
Ow. And it's better like this.
Well, this is the photo that you emailed to me. Then, Victor, it is in the screen, I think.
Yeah.
Probably.
Yeah.
Okay.
Is this
So,
picture, I think.
yeah.
Yeah.
There you can see that that's the situation in June. So you can see that the South Pole is illuminated always, like they told us from HETA, it's the situation. And yeah, then I used to live in Costa Rica, but there the situation was quite different. So we almost do not have any seasons. And I experienced, like in the beginning introduction, that the the polar star was just like 10 degrees over the horizon, and I could also see the Southern Cross. So yeah, I even experienced the sun in the zenith, so we did not have any shadow in April. So the parallel Earth and Sunrise is a simple but very fantastic model that allows people all over the world to observe and to study the illumination of the Earth. Yeah, like phases of the Earth, because you can just put you on an extraordinary place to observe. Thank you very much for your listening.
Thank you very much, Susan. And there are some comments in the chat. Congratulations to you, but not special questions. Thank you. And we introduce the next one speaker is Carlos Moreno from Agora International School in Andorra. Andorra, if the people don't know, is between Spain and France.
Now, hello everyone. I'm going to try to share my presentation. If not, now. All right. I think you can see it now. It's okay?
Yeah.
Okay. First of all, I would like to introduce myself. I live in Andorra. I'm teaching in secondary and baccalaureate, but I would like to share my experience with this project. I live in Andorra. First of all, where is Andorra? You can see there Spain, and then you can see France. Well, you cannot see Andorra because I think we are one of the smallest countries in the world. We are between France and Spain. But it's a wonderful place, as you can see. We have a lot of snow, and when Rosa contacted me just to tell me if I would like to participate, of course, I thought in my students in secondary, and I was to the ground. I went to the ground, and I was trying to do that. And these three children you can see in the picture now, they came to me and asked me, Carlos, what are you trying to do? Well, they were in 5th of primary. They are actually in 5th of primary. And I thought, why not in primary? Probably this project that you have explained much better than I'm able to do it. Why not in primary? I thought, okay, I'm going to change my mind. I'm going to try to take this project to primary because they have the curiosity. They try to do everything alone. That's why we did some mistakes, and I love that because with a mistake we can learn after that. And I thought, okay, I can try to teach basic concepts. Why not? We have concepts of geography, we have maths, we have astronomy, physics, and I remember that one of them, the one on the right, was tell me what happened. They put the doll in Andorra and asked me what happened with the people who is living now in the other side of the planet. Are they falling down? And I thought, this is the question that always we do. And I don't know, actually, I told them, I don't know. Why don't you investigate it? And that's what we are going to do now. I didn't want to talk about gravity, about the Earth, but they have questions, they have curiosity, and I'm going to take this project as a starting point just to develop different concepts in primary. And that's why I have to say thank you, because it was going to be a project for secondary, but now it's going to be a big project for the whole year. And we're going to talk about parallels, meridians, what's the equator, basic concept, what's a magnet, because they use a compass and they didn't know how to use a compass. It was the first time. And it was so surprising for them that I want to thank you for Rosa and you, all of you, because it's going to be for me one big challenge for this year. And that's our pictures, what we did. They make a mistake because they put in the right direction our Earth, but then I asked them, what have you done? And they didn't know which was the part north of our little country. And I thought, okay, we have problems. We have to talk about everything. And that's what we did. I hope I can help with this project. And that's all for Andorra. Thank you very much.
Thank you very much, Carlos. I think it is a very nice experience with your children, your students. And I hope that you continue working with them, because this is only the beginning, okay?
Thank
you,
will.
Carlos.
Thank
the
you.
Next one speaker is from Spain, from Granada, is José Manuel Escobedo.
Hi.
From the school, the Colegio Andrés Segovia.
Okay, thank you for this chance and this challenge. Firstly, I am in Granada. Granada is in the south of Spain. Perhaps you know the Alhambra and Arabian Palace. And I am going to start with the final. I don't have a PowerPoint. The last part of my job was this, a photo where you can see the photo is perfect. It was in the equinox, and you can see that the shadow is in the middle, but the photo is perfect. And for me, it was a sign, a clue that the job was made. I mean, the boy was understanding what's happened. he was able to understand what was made with the sun and the shadows and all the movement about the project that we were doing. I need to say that my job with, have you seen the photo?
Not yet.
How to share my screen, please?
Probably you have on the right part one information that you have in Spanish, presentar ahora.
Okay, I have it.
Yes.
I have it. Yes,
okay.
You can see me?
Yes.
Okay. What I want to show is the photo is the most important is this. I was talking about that. And I was talking about the clue about the comprehension of the task. So when I started with, sorry, what happened? Oh, okay. When I was starting with the project, we were confined. We were inside homes. We could we could stay in touch. We couldn't be with the students. So all the project was online. It was very difficult to explain what was the experiment, but I tried it. In the beginning, my students from 6th grade started with it, and some of the 5th grade started too. But along the time and with the holidays in summer, my student was out except one. Finally, one was finishing the work, and the photo is from him. I am here, sorry, he is here with his father, and for me, it's a pleasure to give him the time that rest to finish my presentation, because if I am here, it's not only for your invitation, thank you, Rose, but his own work. If you're here, David, please read your test. I am in home too, because I am ill. I can't work. Okay, so I am not in class. I am not in school. I know that he was here. Can you see my student, Rosa?
Not yet.
Not yet. Manolo, are you here? Oh, it's a pity. My final sentence, I'd like he could speak now, but finally, something that students and kids are awesome and always are surprising me. The last message that he sent to me was, finally, I have an argument to destroy the idea of flat Earth. Wow! It was awesome that now that something so stupid idea from a student that I was forgetting the discussion about that obvious wrong idea, and a student from me was able to combine the experiment from something very, very current, very actual problem in science, not in science, pseudoscience, like that. So it was my experience, very condensated, and thank you a lot for the opportunity. It's a pity he can't speak, but the time is limit. Okay?
Yeah. Yes, I didn't see your student. I don't know, but maybe Victor, you can see him?
No, I can't
No.
see him.
Okay.
No.
Okay.
Barbara has said, I think. Barbara has said that.
I don't
Yeah,
know.
but-
Maybe, I don't know. It's a mistake. Well, thank you very much, Jose Manuel. I am very happy that you participate with your student, that we have technical problems. But in any case, In any case, thank you very much. This is Manuel. Manuel.
Yeah, I can see it now. Yeah.
Oh, yeah. Sorry. Thank you, Barbara. Well, yes, please, Manuel. Hola. Hola, ¿qué tal? Do you want to explain us what you work and your feeling about your activities with the Parallel Earth?
David is going to read his own reflection about the experiment. So he's not good about English, but well, he can read all things he's been thinking about the project. Please, David, proceed.
Good afternoon to everybody. My name is David. I'm 12 and come from Granada, Spain. And I am very, very pleased to take part in this fine event of the Parallel Earth Experience project. First, I would like to thank my teacher, José Manuel Escobedo, for supporting my all through these past months. He has taught my aunt the rest of my schoolmates to love science and research, observing how the Earth moves around the scene, the passing of seasons, and watching the sunlight and shade. On my homemade glow placed on my terrace. This has been an amazing experience as well as taking pictures almost every week from June to September. All of this has and encouraged me to keep on studying and raising awareness about of planes and how to take care of it. Thank you very much.
Thank you very much, David. I remember your work. I remember that I received several reports from you, not only one, not only two. You sent to me a lot of them. That means that you work for a lot of time. Muchas gracias. Me acuerdo muy bien de todo lo que he recibido de ti. Has trabajado mucho y no me has mandado una foto, me has mandado un montón de fotos y lo has trabajado. Por tanto, felicidades, lo has hecho muy bien. Tienes que estar orgulloso. Un beso bien gordo. Gracias. Congratulations. I kiss you. And thank you to the family and thank you to José Manuel. And I am really sorry that I didn't see you. Sorry. Thank you. Bye-bye.
Bye-bye.
Bye. Well, thank you, Barbara, to say to us that David was here because I didn't see really. What the problem was the name of the father that disoriented me absolutely. Well, thank you very much. And the next one speaker is Abdoulaye Bakoto from Senegal. He's member of the, he's one research student in the University of Dakar. And what is Abdoulaye? Are you here? Hello, Abdoulaye. We can see you, or you have problems with the connection? I don't know. What is him?
Yes, I can see it.
Okay.
But open your microphone, please.
Abdullaye, open the
Yes.
turn off on the micro. Turn on the micro.
Okay,
Ah,
okay.
excellent.
Anthony,
We can see you. Excellent. Thank you very well.
thank you.
Well,
I want to say hello for everybody, and I think that you will understand my English is not very excellent. And my name is Abdoulaye Ba. I am in University Cheikh Anta Diop in Senegal. I do my PhD in astronomy and astrophysics. Okay. Hello, Rosa.
yes, Abdullaye. I would like to ask to you what was the problems that you have to find a parallel to find a terrestrial sphere, because you have to use a different device, no? Could you explain to us the difficulties and how you solve them?
Okay. Firstly, I say thank you, dear Rosa, for inviting me to participate in this beautiful initiative for astronomy. I also take this opportunity to greet all the people who had to participate in this event. So I will be very happy to answer this important question asked by Rosa. Firstly, I want to say that it was too difficult to have this terrestrial sphere, because we all see it in this period of pandemic. Things are very difficult. Firstly, I teach here in our laboratory and our university, and I had not seen it. Even one of my professor had it, but he was on vacations. I couldn't see it. Afterward, I went to some teaching college, but unfortunately, they were closed because of the pandemic. Then I went to the market, but it was too expensive. The terrestrial sphere was too expensive, about 800 here in Senegal. And since I didn't have any money, I couldn't get it. And finally, I bought an air balloon. You can see it here, an air balloon, and I inflated to have a model of terrestrial sphere. And I put a Burnham here. You can see it with a red color to make a simulation of the experiment. But I want to say it was really difficult, but I was determined to do it. That's the way I am doing to have these models.
Thank you, Abdoulaye. I remember all the times that you participate in our projects, that you have always a collection of small children with you. In this case, you only send to me this picture, but next time send me with your wonderful friends that work in astronomy with you. Thank you very much. We don't have any question for you. And we are very late, and then I would like to introduce the next one speaker. The next one is Ivo Jokin from Bulgaria, from the Baikal village. He is a member of the Municipal Center for Extracurricular Activities in Dolna Mitropolia in Bulgaria. Thank you, Ivo.
Thank you, Rosa. Are you hearing me?
Yes.
Hello, everybody. I was nice to meet all of you from all the world. For me and my students, was very happy to participate in Parallel Earth. So we are organizing and conducting this experiment with references and bibliography from Rosa. This Earth Ball, we use the Earth Ball from Universe Awareness UNAVI project. I have, how to say, idea for how to use Parallel Earth. Also this installation, this experiment, and how to use, for example, students' schools' video system control. As you know, each school we have video control. So, for example, in Bulgarian, we have one mount. After that, this movie goes to archivate this data. But we can use, for example, one day per week. After that, we can make several photos. For example, we can put one gnomon on the square, school square. And first week, second week, third week, we can take photo, and students can measure. They will observe that the shadow will be changed during this period. For example, we can start with students July, August, September, October, and students every day maybe, or one day per week, take a photo of they can measure a photo, the height of the shadow of this gnomon. Another good idea, this is we can measure how high by each shadow at the time of the local noon, the moment when the sun is highest above the horizon. For this purpose, we need to make a special solar meter. It shows the length of the shadow of a person of a certain height on the days of the summer and winter and autumn and spring equinox.
Oh, thank you very much, Ivo. Wonderful presentation. I believe that we don't have any question in the chat for you. No. And then thank you. And I think it is very interesting that the municipality offer this kind of projects for people.
Sorry, I would like to show ladies from CETA. CETA also work with this Parallel Earth.
Nice to meet you. Excellent. Congratulations. It is good to have a team of people who can go together because I want to take a picture. Okay. Thank you very much. And I hope to continue working with you, of course, and with the rest of the people in this project and other ones. Thank you very much. The next one speaker is Jose Maria Gomez from the Observatorio Astronómico Professor Alexis Troche from Paraguay. It looks that he is in San Lorenzo, but he works also, I think, in the university in Asunción. Then Jose Maria, thank you very much to get up this morning so early. Thank you.
Hello, everybody. Can you hear me?
Yes.
Well, I want to share my presentation with you.
Yes, thank you.
Okay. I have some just a moment.
You have to go to the right area of your screen and you have in Spanish presentar ahora.
Yeah, just a second. I have some problem here.
Okay.
But I will solve it. Could you see the screen right now?
No, not yet. We don't see.
Maybe it's the internet connection, but well, let me introduce myself. I'm Jose Gomez from Astronomical Observatory, Alexis Troche of National University, and I've done this experience, and it would be better if I could share with you the presentation. Okay.
Don't worry, maybe you can explain to us your experience with your students.
Well, I have done this experience in 2 days. One from home in Caacupé, 50 kilometers from the capital, Asunción. And the next day, the experience was in the near Asunción and the observatory. And this experience helped me to explain to the student by a blog article how the solstices works, and help me to explain to the student how the vertical sundial that we have in front of the observatory, how that works near the solstice.
Jose Maria, we can see that you are sharing your screen, but it is not your presentation, it's only the screen. Now.
Oh, now.
Yes, now yes. Yes, wow. We lost it.
Okay.
Now,
right now?
yeah. Okay. Okay. Yes, now, please. Explain to us. Yeah.
Well, as I told you, I am for Astronomical Observatory of Paraguay. Our country is in the heart of South America continent, here, 25 south latitude and 57 of longitude to the west. And in the middle, between two big countries, Brazil to the northeast and Argentina to the southwest. And we are here in the middle.
Mm-hmm.
I use this globe to the experience, and the first day I made experience in Caacupé, where living is a city known by the religious matter, and I took these elements in front of my home to make experience. We have a problem with the COVID-19 and that is because I could not do it with the students. And the results, as it was expected, show in the 25 of is under shadow, and the North Pole is, of course, at summer. That is what expected because, as you know, is winter in the South Hemisphere, and in the northern is the summer. I used the compass and I corrected the orientation by a declination. Our view of this piece is this, showing the South Pole at dark, and the southernmost point in the continent showed 15 hours, local hour. It was not at night yet. This was of 25 of May. Almost 1 month later, in 20 of June, near the solstice, I went to in front of the observatory, near the Asunción of the capital. I went there and I made the same experience. And I found almost the same result as it was expected, but a little difference found. You can see in this picture, near the solstice, the southernmost point of the continent is getting dark 1 month later. This was in May and this in June. Well, for this experience, I learned how has changed the shadows in the earth near solstice, and the experience helped me to explain by a blog article how vertical sundials works. Thanks.
Well, thank you very much. Finally, it's running in your PowerPoint. Thank you, Jose Maria, and thank you to participate because I know that the difference time is not very nice for you, and it is difficult to participate from Paraguay in this hour. Thank you very much. And the last one is short presentation.
You're welcome. You're welcome.
Yeah, is Mirjana Bosic. Mirjana Bosic is from Serbia, but he is working now in States, in Boston, and the presentation is about the experience that she had in Boston, in the States. Mirjana, it's your turn. If you want to share with us a PowerPoint.
Good day. I'm happy to participate. I hope that you see my presentation. Is it visible?
Not yet.
Not yet. Sure. Is it now visible?
I cannot see, but I don't know other people. Not yet for me.
No.
Okay.
Now.
Now, yes.
It's not.
Now,
Is it now?
yes. It's fine.
You
Okay.
see it? Good.
Yeah. Yes.
So when I saw at the site of the International Year of Light the announcement of this project, I was very happy because I started to write about day-night year globe or parallel globe, and now it's called parallel Earth. I started to write with my colleagues in 2005. So in 2011, in Serbia was built of concrete, a big globe, which you see on this picture in the town Shabac, and it became the symbol of Shabac. And this is the picture announcing activities in the science park and on during this year. But since this year I spent in Boston, I joined the project by doing experiments in Boston, and at the same time I communicated with my colleagues in Shabac and in gymnasium, in high school in Zemun, who are also very happy to participate in this project. So this is the picture made by students and professors in high school in Zemun. They just contemplated in April the passage of the sun through the meridian plane. So next I shall show you the photos which we made in Boston, our team for open science in open space. One of I hope that you see the globe which I have in my hand, because I do not see. Okay. I like this variant of the globe because this is a globe which you can easily put in the right position, that the place where you live in is on the top, and that the axis is parallel to the Earth axis. And this small libella is also ideal for doing for making this in the right position. So that is a picture during solstice, in which you see that South Pole is in darkness. And what is important, it is important, our goal was to record the whole terminator by recording from various sites. That's very nicely seen here. So during solstice, this line between day and night makes an angle of 23 degrees with meridian. That's seen very well. And since we are in Boston, at the time when the time is solar noon, this terminator is at this position, so they have dawn. These are these pictures from solstice, and here night already came to Africa. And now these are the pictures from September, from equinox, when the line between day and night is along the meridian. That is well seen here. And also we see where the position is. I want to stress again that is the night-day line, and we compared by calculating, compared at what time is, whether it disagrees with the information we have, at what time comes the night. at this place. You see here, downtown Boston is in the background. I just a few more minutes, please. One day I made observations at the street, and then people were passing by me, and they stopped the car and they asked me, "Are you selling this globe?" And I said, "No, I'm not selling. I'm recording the day-night line, and this is a parallel Earth." And they were very surprised, and then I explained them about the project. But they were from Africa, and a man from the car said, "Oh, is it Africa?" Because he saw, I hope he saw Africa. I say, "Yes, it is Africa. I'm born at the west side and in West Africa." And he was very happy. I continued to explain about it, and they were very thankful. In my communications with Serbia and also with Richard Barreford here from United States about Meridian, we in Serbian Gymnasium in Zemun, after this project, they decided to form astronomical corner in their school, which is now at the moment of, at the time of renovation. The school is renovated, and they will form astronomical corner. They are also planning to make an internal meridian. So, in fact, we experimented in the, inside the school and inside our homes, and it's nice to make an internal meridian in your home just by near the window. You just put a thread along the window, and you determine, knowing when it is solar noon, you determine the direction, and then you can also observe your globe inside the school and inside your home. So this is our next step, and I think maybe in the next year, this parallel Earth project could be enlarged with building internal meridian in the schools. I would like to say also that I enjoyed very much the lecture of Nicoletta Lanciano, because I read the articles which she published in physics education with her colleagues, and I especially like and propose to everybody to see this article and to see the supplement with a very good video about experiments about this global local, but with a music which is very nice, which accompanies all pictures. Thank you, Rosa, for initiating this project, and thank you all for presenting this. I enjoyed participating, and I enjoyed that we continue this.
Thank you very much, Miriana. I think that we don't have any questions, and also it is very, very late because it will be finished the session, and we have the last one speech, the last one lecture by Juan Antonio Prieto and Maria Pilar Orozco, that they, both of them, they work in the Colegio Huerta de la Cruz in Algeciras, and they have a project this year. This is a special year because it is a very difficult year. You know that all the schools have difficulties in order to teach. It was closed and it was not possible. But in any case, they prepare a general project with a lot of different activities, and in some way it could be the summary of different presentations that we have here. I imagine that Maria Pilar Orozco is there. I saw before Maria Pilar?
Yes, I'm here, Rosa. Hello. Hello to everybody.
Antonio, both of them, yes. Thank you. That you want to share with us your PowerPoint?
Yes, of course.
Thank you very much.
While Juan is presenting the PowerPoint that we have prepared, I would like to present ourselves. We are both teachers from a school in the south of Spain, Huerta de la Cruz, and we also belong to a scientific association called Diverciencia, and we do lots of small projects with our students in both primary and secondary schools. Okay, we would like to start presenting to all of you all the observations that we have done. The first one is the easiest and obviously the most common one, which is day and night. For this observation, what we did is we placed a parallel earth in the schoolyard, and obviously the one part of the earth is illuminated, that would be the day, and then you have another part of the earth which is dark, which is the night. And in between the two of them, you have a line, a twilight zone, which is the sunrise. And you can see in our pictures on the top hand corner the date in which the experience has been made. So that will help you place the seasons and the weather under the conditions we have worked. Okay. A few days later, what we did was to study the polar day on the Arctic. Being summer on the northern hemisphere, we can tell, or we can see that the whole north ice cap is illuminated. And in here we say that it would be illuminated for 6 months. That's not correct. It would be, the days would be much longer, and some of them would be fully day and not night, but not doesn't last 6 months. Similarly, when it's winter in the southern hemisphere, the Antarctic pole, the South Pole on the Antarctic will be dark for most of the 6 months, and that would be the polar night. The second observation has to do with the terminator and the seasons. The terminator is a moving line that divides the daylit side and the dark night side of a planetary body. Here on the moon, you can observe it very clearly. When it's summer on the northern hemisphere, you can tell the terminator dividing the lit part of the globe and the dark side of the globe. Some on the northern part of the hemisphere, and in this picture you can see the same event through the equator and through the North Pole. Similarly, when it's winter in the southern hemisphere, you see the terminator, and we have shown in many of your pictures, and we see that the south hemisphere is mostly dark. On the days of the equinox, both in spring and autumn, this would be the autumn equinox, the terminator runs through the poles, from the South Pole to the North Pole. Observation 3 would be about midday, midnight, and the solar zenith. The solar zenith is a point in which you feel that the sun is directly illuminating you on the top of your head. So you wouldn't project any shadow on that point. In our globe, we have signaled the solar zenith, and also we have signaled the meridian in which that solar zenith is placed. Along all the places in the meridian would be midday. And if you continue the meridian on the other side of the globe, it would be midnight. Observation 4 is how to measure the radius of the Earth through Eratosthenes calculations. Okay, the little figure shows Spain and the position of the globe. That day, the solar zenith at the moment of our observation was on Mozambique. I have to tell you that these calculations and this experiment was performed by our oldest students, which are 15 years old at the moment, okay? So the students placed a pole on the schoolyard, and we measured both the height of the pole and the length of the shadow that the pole projected. And through the equation of the tangent, we were able to calculate the angle. Once we had the angle of the solar rays on our schoolyard, through Google Maps, we measured the distance between Spain, the south of Spain, and Mozambique. And due to a relation of proportionality, we were able to calculate the curvature arch of the Earth, being the curvature arch 2 pi radius of the Earth radius. And now, after clearing the radius and doing the calculation, the result was around 7,234 kilometers. Obviously, there's a small error there because the radius is 6,700 kilometers, and we believe that Google Earth is not very precise in the distances. And that was the origin of miscalculation. Okay, observation number 5 is when is it sunset? We have a parallel Earth, and we define where is the terminator. And then we have Spain, and we drew the meridian in which Spain is placed, and also the parallel that runs from Spain to the terminator. This parallel is cut 3 times by 3 different time zones. So therefore, if in the meridian is 8 o'clock, in Spain would be 5 o'clock, and it would take 3 hours before sunset. This is a bit more difficult to explain using a beach ball, but if you have a look at the picture on the left, we can see the model that we have in Santander, in which all the times are written around the equator circle, and with that little inscription, and using terminator, you can calculate the time. If we do the same kind of process in our beach ball signal in Spain, we know that in the terminator is placed in where we're showing in Spain would be 8 o'clock solar time. And now, if we want to know what's the time, for instance, in Paraguay, if we know that in Spain is 8 o'clock and Paraguay is 6 hours less than in Spain, therefore in Paraguay it would be in the morning, okay, solar time. Observation 6 is about the evolutions of the normal shadows. This also has been shown by some of your presentations, particularly Carmen. I can remember it was a beautiful presentation. Okay, so what we did was we placed normals along the meridians and the parallels, and we studied how the shadows were changing through time. Each of the pictures was taken with an hour difference. We can see that on the parallel, the shadows move from east to north and then to west in the northern hemisphere. Here we show them in detail. And first, in the meridian, they go from east to north to west in the northern hemisphere. In the southern hemisphere would be east to south to west. And in the parallel, exactly the same. The shadows will have all the same length, and they will move east to north to west, west to north to east in the northern hemisphere. The interesting thing is that in the parallel, all the shadows have the same length, but in the meridian, the ones closest to the poles are longer, and the ones closest to the equator are shorter. And therefore, it's a very good starting point to explain the climate in different parts of the planet. Explains particularly young children who are colder on the poles and along the equator. Finally, we want to show you all the different observations that we have performed. The letters P, S, and H in red signal that you can do this observation with primary, secondary, or high school, okay? So we have determined the solar zenith. We have also determined the approximate time of the sunset and sunrise. Also, we have observed that certain areas of the Earth are dark while others are sunlit, the direction in which the sunlit areas advances. We have also observed that on the northern hemisphere in winter, the North Pole does not receive solar radiation. Also, we have observed that on the first day of spring and autumn, the terminator is placed along the axis of the Earth. And also we have observed that the meridian, and in the meridian, the terminator moves along by 15 degrees every hour. So the time in every part of the planet can be calculated. Similarly, if we use gnomons situated along a single meridian, we can study that it is the same time in all the places on the same meridian, that the shadows produced by the gnomons move in the same direction, but the direction of movement varies depending on the hemisphere. The shadows point to the west in the mornings, to the north at midday, and or south in the southern hemisphere, and finally to the east in the evenings. We also have observed that during sunrise and sunset, the shadows are very long, however, are shorter at midday. When closer to the equator, the shadows are shorter, whilst they are longer if they are closer to the poles. And finally, that we have been able to calculate the radius of the Earth through Eratosthenes' calculations. After making all this observation, it can be concluded that there is always the same time in the places situated in the same meridian. The sun rays penetrate the atmosphere with an oblique angle around the poles, and the oblique incident of the sun rays around the poles is responsible for colder climates. Now, if we place the gnomons along the parallels, we can see that as the day progresses, the shadows move from west to the east, passing through the north, south on the southern hemisphere. So the approximate time of the place of observation can be calculated. And if we make observations over the year, we can see that the Earth's revolution around the sun causes the seasons. When on the northern hemisphere is winter, on the southern hemisphere is summer. And in summer, there are more hours of sunlight than hours of darkness. And on the north ice cap, the sun never sets, or almost never sets, or very little sets. And however, in winter, there are more hours of darkness than hours of sunlight. And in spring and summer, the hours of light and darkness are very similar. As a conclusion, we would like to tell you that the parallel Earth we have found is a fantastic way and a very intuitive method to explain aspects and events of our planet that can be difficult to visualize in the classroom. Students are fascinated by learning about the Earth and the solar system. However, for the teachers, sometimes explanations can be very difficult, and we find ourselves very often, for example, using oranges in skewers and lanterns and lamps to explain different aspects of the seasons, and with little success. So we strongly recommend performing the experiences that we have presented in order to engage your students in the scientific knowledge through an active learning process. These are the references that we have used to do our work. And we only have to thank you for your attention, and hope to see you very, very soon with another fantastic project. Thank you very much.
Well, thank you for your contribution. I don't know if there are any questions, maybe some comments. Somebody wants to mention something. I don't know. In any case, I would like to mention that it was an impressive situation to have in some moments 40 people, all of them working about astronomy and talking about this project concrete, the Parallel Earth, that I think is one of the best experiments about astronomy because it is simple and it is impressive. I remember that several years ago, Carmen Alemany said to me one anecdote, one comment, but funny, very funny, because she said to me that presented during a visit of the families to the school and explained the Parallel Earth, and one of the parents asked to her, well, you explain all of this about the movement, the sun and the earth, but what is the engine that really moved this? No, because he cannot imagine that it was not possible that to have something with electricity, with something energy, no, that moved this parallel earth, no, and really nothing, no, it is reality, the normal movement of our planet that it is involved in this. I think it was a very special, fantastic situation, and in some cases for children maybe no, but for people, older people that, like us, no, that it is very surprising that this simple thing, simple device, offer us the possibility to observe the Earth from a rocket position. No? It is very, very special. No? Then, thank you to all of you. Thank you especially to Nicoleta Lanciano that it was here. I know that he have to go to the dentist, but she decided to cancel the dentist for the Parallel Earth, and I want to say thank you, Nicoleta.
Grazie a voi. Molto, molto bella questa mattinata, molto ricca.
Grazie. It is a pleasure for me to see you again by computer, but well, doesn't matter because face to face, for a lot of years, we didn't have this opportunity. I hope that we can do it in the future when the pandemic finishes, because now our situation it is a little difficult. Well, in any case, thank you to Carmen Alemany, that it is in Spain is a reference person for the Parallel Earth. And I think it is 20 years using this device with children. Of course, this is an encyclopedic information that she has, no? And it was very nice that explained to us. And also I want to say thank you to Jose Antonio Prieto and Maria Pilar Orozco. I am sure that to synthesize, to put the summary with a lot of different activities that all of us, we know that the Parallel Earth is useful for a lot of possibilities, no? But I think it is interesting to have a so structured program that probably there are other things that there are not there because there are a collection, but in any case, it is interesting. I want to say thank you to all the people that participate from different countries. I think for us it was very important to have this contribution. There were several countries that participate also in the project but cannot participate in this meeting. And I think it is very important for us to have this possibility to show in general, you know, that all of us, we are learning during all our life. And this is one opportunity more in order to learn from other people. Yes. Thank you very much. I participate in a lot of meetings and I use the Parallel Earth for a lot of years, but I listened some comments or some aspects that it was new for me. Then I think it is very interesting to learn always. Yes. Thank you very much. The last comment that I would like to say is we plan to prepare a very small book with appears all the people that participate with their contributions, but it is not a proceedings. The idea that they have is to prepare a book very nice with photos for us and for children also, and including different approach to the Parallel Earth. Then I would like if you can email me the PowerPoints in order to remember all your contributions and after to invite some of you to participate in the book. I don't have a lot of money. The book should be very small, but in any case, I think it's better this than nothing, okay? Then I will try to invite some of you to participate with us. And in any case, thank you. And I promise you that NACE will organize another project next year with a different device, with a different possibilities, very simple also, not expensive, you know, the mentality of NACE, only one stick, one string, and I don't know, one piece of carton or something like this that you can work with us, okay? A ball, of course, a ball is very important. Then all of this is part of our life, part of astronomy and part of science. Thank you very much and see you again in the future and in next projects. And I would like to invite you to participate in Ciencia en Acción that we begin after lunchtime, and it will be online also. If you are interested to participate, you are welcome. The language in Ciencia en Acción is the official language are Spanish, Portuguese, also all the languages official in Spain. It is Catalan, Euskera, and Gallego. Okay. Then, if you want to participate, you are welcome. And thank you very much for your interest and your help, because we only can organize this kind of events if you help us and you work with us. Thank you very much and see you again in the wall or online. Thank you. Bye-bye. Bye.
Bye. Thank you.
Bye-bye. Thank you, Rosa. Bye.
Bye.
Bye.